I've got a couple videos posted here you really should watch before you even start this. But Newton's Law 7. And the very first thing I would make sure that you know, as I already mentioned in the past, is to be drawing pictures of what you have going on. Make sure to have your notes out, drawing pictures, make sure to have your notes out and be using equations. This is critical when you're working on these. If you ask me for assistance, I'm likely going to tell you to do this and then wait until you start that before I come back, because it's really important that you're working on that. This first question talks about a Daryl Duvall. He's jumping out of an airplane and he's reaching a, says in the first 2 minutes, his 79.3 kilogram body eventually reached the terminal velocity, and it gives you the velocity that's at by the end of the two minute mark. It's saying, what is the net force on his body at this moment? I've gotten a lot of questions about that. This is one of the reasons why you should have your notes out. This is some notes that I gave you. Terminal velocity is when air resistance equals the force of gravity. So if you were to draw a little bit of a force diagram here of this guy who's falling down, what it's basically saying is there's the force of gravity, and then there's the force of air. And when you're in a state of terminal velocity, these two here are equal to each other. So then if you were asked the question, what would the net force be, as you are, what is the net force? Well, the net force would be 0. And then likewise, what is the force of air resistance on his body? Well, you're going to have to use that little tip that you figured out there. Well, you know the force of air resistance is equal to force of gravity. And can you find force of gravity? You certainly can, using one of your equations that involves his mass and acceleration due to gravity. This next question here, I've received a few questions about, and so I wanted to do just a quick explanation here. It talks about, it gives you the mass of a bucket of water, and it's raised upward by a rope attached to it. It says the upward acceleration. It tells you the acceleration. Then it wants to know the weight of the bucket, and it wants to know the net force experienced by the bucket. And so the first thing you really want to do is kind of visualize what's happening here. So what the question is describing is a bunch of water, which of course has a force of gravity on it, being lifted up by a string or a rope. And so if you can imagine what we would call the forces, force of gravity is downward on that. And then the force of tension on the string is upward. And if we back out here, I don't know how well you can see this, but you could actually measure that force of tension. This rope or string or whatever is transferring the force this way. And so we could sketch this out, and we know that there's the force of gravity going downwards. And now we know there's a force of tension going upwards, but the one thing we do know that is this thing accelerating. And yes, it is. Now what this tells us is, second law says if something's accelerating, then there is a net force in the direction of the acceleration. So there is a net force. It's accelerating upwards. What that tells us is we don't know the value of this force of tension on the rope, but we do know it's going to be bigger than the force of gravity. So in our little sketch here, we could just draw it longer, just to kind of help us know that. So we know that the force of tension is going to be larger than the force of. So the way that we can solve for how much larger it is, we have to essentially work backwards and understand that our acceleration will help us know what our net force is. And what we would do for that is we start out with our equation, force net equals mass times acceleration. And we could jump over here to our original question here, and it's going to tell us both our mass and our acceleration. So our mass is 4.68, and then our acceleration, I'm just reading from the problem there itself, and mine it's 1.34. Your numbers will of course be different. So from that, we can of course solve for the net force. To do that calculation, my numbers would have us having a net force of 6.27. And so now what we do need to know from this is, what we can effectively figure out is, this force up here, the force of tension, is going to be 6.27 newtons. I should add that. Newtons larger than the force of gravity. Now, there are a couple of more equations we can use to solve this. You should be getting a little comfortable with them, but I'll show them to you and how to do it. The first one is the force of gravity. We can calculate this easy enough because it's just acceleration. I mean, it's just mass times gravity. We know the mass. So that would be equal to 4.68 times 9.8. And if I run those numbers through, we find the force of gravity equals 49.86. And I'll even add that down here, 45.86 newtons. Always add those units in. 45.86 newtons. Now, to actually solve for the force of tension, what we have to realize is another equation, and that is that the force net is equal to the sum of the forces. Now, I personally think it's better if you can visualize and think about, well, if this is 45.86, and we know the net force is equal to that number we already wrote down, 6.27. If you can think, well, this force here needs to be this much bigger than this force, you kind of get that you need to add these two forces together to figure out what this is. But if that logic and that thinking through is really difficult for you and you just love equations, it is the equation for this is force net is equal to the sum of the forces we call up positive and down negative. So you could put in everything you know. 6.27 is a net force upward, so it's going to be a positive number. That's going to equal, you've got a negative for force of gravity, it's going to be negative 45.86 plus your unknown of your force of your tension. And either way you do it, you're going to find that with my numbers that I've had, 52.13 would equal the force of tension on this object. I have some other videos looking forward into the next part of this, but hopefully that helps. Thank you and have a great